So this question is another relatively simple question, simply stated, not necessarily a simple physics question, but it says, can you have an object with zero velocity, not with an acceleration, an a, not equal to zero simultaneous? So a non-zero acceleration and a zero velocity. X equals x naught plus v naught t plus 1/2 at squared, and v equals v naught plus at. Acceleration is not equal to zero, but can I have a zero velocity? Well, if I look at these equations, I could just, in this first equation, set v naught equal to zero. This is us sitting at a stoplight. As soon as the stoplight turns green, we hit the accelerator on the car, hit the pedal down. We have an acceleration, but we haven't moved yet because our initial velocity is zero. So this case is possible. There's another pretty common case that I think is good to go through. Say that I have x and y. I'm just going to look at the world, and I'm going to take myself, put myself down here, and have a baseball. And I'm going to throw this baseball straight up, and it's going to come straight down. It doesn't look like it came straight down, but you wouldn't be able to see it if I didn't draw it slightly apart. So assume the ball goes straight up and straight down. Well, we know that in this entire case that our acceleration is equal to gravity, and it's pointing in a downward direction. So our acceleration is downward 9.8 meters per second squared. And that's going to be constant for both of these terms the entire time. My initial velocity in this case, because I set y to be positive upwards, is going to be a positive value. So my initial velocity is not equal to zero. However, when it gets to the very top, the acceleration is going to slow the velocity down. It's going to be going up. It's going to get slower and slower and slower. So our velocity vector is going to go very slow. And when it hits the very top, the velocity at the top goes to zero. At the very top, the velocity is zero, but the acceleration is still downward gravity. It's going to start at the top. It's going to get slightly larger as it goes down. So my velocity is going to start at the top at zero and get larger as it goes down. So there's a wonderful little case when you get to the very top, you go to zero. This kind of makes sense. The velocity is positive, then the velocity is negative. If a velocity goes from positive to negative, at some point it had to cross zero, assuming that it's continuous, which throwing a ball up is continuous. So the correct answer for two different cases, starting at a stoplight and hitting the accelerator, our initial velocity is zero, or throwing a ball up and coming down, the velocity at the top is zero, but the acceleration is still gravity. So both cases show that you can have zero velocity at some point with a non-zero acceleration.